Hello and welcome back. In this section 3, we go over logistic regression. More specifically, in this section, we are going to take a look at logistic regression with categorical response variables, which are at two levels. And then we look at the model and its interpretation. We also go over misclassification, error, and confusion matrix, followed by ROC curves. And finally, at the end of the section, we look at prediction and model assessment. So in this video, we go over logistic regression with categorical response variables, which are at two levels. So in this video, we are going to take a look at the data, and we'll also see what is the structure of the data. We will also summarize the data, and then we go over cross tabulation of categorical outcome and predictors, and then if required, we are going to see how to change a variable to a factor variable. We'll partition data into training and testing, and then we will develop logistic regression model using the training data set. So let's first read the data into my data. So this data set is in CSV format. So I'm going to use .csv, and also it is on my desktop. It's called binary.csv. And the first row contains names of the variables. So for header, I'm going to say true. So note that this format using this tilde sign and then desktop. So this works on Mac. If you have Windows computer, you have to use the full path name of your file. So you can see this data is read. It has 400 observations and there are 4 variables. So let's look at the structure. str. So it's a data frame, rows and columns, 400 observations, so 400 rows, and 4 variables in 4 columns. First variable is admit, and it takes values like 0 and 1. So this data is for whether or not a student was admitted to a college. So students apply to college for admission, and the process is to look at what is their GRE score, what was their GPA, and what was the rank of the institute from where they are coming. So for example, if an institute is ranked as number 1, so that means it's a very good school from where this student is coming. But if it is 4, so that is the lowest rank. So using GRE, GPA, and rank of the college, a university or a college decides whether or not we should admit that student to the college. So one thing you will see is, because this is 0 and 1, R thinks that this is an integer variable, but in reality this should be a factor or a categorical variable. And especially in this case, because it takes only 2 values, where 0 means not admitted, 1 means admitted. So this factor variable has only 2 levels. Similarly, if you look at rank, so 1, 2, 3, 4, so this is not an integer variable. This is also a factor variable. So we have to convert these two into factor. If you want to look at first few rows of the data set, you can say head, my data, and first 6 applicants information is given here. So first applicant was not admitted, and this applicant has a GRE of 380, GPA 3.61, but belonged to a college or a university that had a ranking of 3. Now second applicant has quite good GRE score, so much higher than the previous one. It has higher GPA, also slightly better than the previous one, but from where they are coming, so there's no difference there. So not much difference, but still this student is admitted because of high GRE, high GPA. So the idea is, can we develop a prediction model where the model looks at these 3 numbers and then makes a prediction whether a student should be admitted or not. We can also do a quick summary. So these applicants, you can see, have a minimum of 220 GRE and maximum 800. Average is around 587. Lowest GPA of applicants is 2.26, so this is very low. and maximum is 4. So I'm sure this student was admitted, and then you have these rankings. Now let's do a cross tabulation. So function we use is x for cross tabs, and we want to do this for admit plus rank. So we want to use these two variables because they are supposed to be categorical, and our data is called my data. So the idea behind creating this cross tabulation is to see if we have a situation where any of these cells has low value. So anything which is less than 5, so probably we have to do something before we can really analyze the data. So right now we have minimum of 12, so everything looks good. So before we do anything further, let's also convert admit and rank to a factor variable. So we want to change admit variable as factor. So we'll say my data $sign admit. We can do same thing to rank. Now if you quickly want to look at the structure of my data, you can see that admit is now factor with 2 levels 0 and 1. Rank is a factor with 4 levels with 1, 2, 3, 4. So now we can do data partitioning. So to ensure that we have repeatability of results, and when we do the data partitioning randomly, we get same numbers in training and same observations or numbers in testing. So what we do is we make use of set.seed. So we can use any specific number. I'm going to use 1, 2, 3, 4 and run. And then let's store within I and D, which is like for independent samples. So we'll create 2 independent samples. So 2, and this will be from my data. So let me hit enter and write this in next row. So this is with replacement, sampling with replacement, and let's use a probability of 0.6, 60% for training data and remaining 40% for testing data. So we run this. So let's use training name to extract from my data when I and D is equal to, so 2 equal signs, 1 and then comma. Testing is the remaining 40% where I and D equals to comma. So when we do this, you see that training data has 249 observations and testing has 151. Make use of 60% and 40%. You may not get exact 60% or 40%. So it will be approximate 60 and 40. So now we have split the data, and now we have training data set on which we are going to develop logistic regression model. So the reason we are using logistic regression model is our y variable or the output variable or the independent variable admit is a factor variable. If this variable was continuous, then we should have used regression or normal regression or multiple linear regression. But because it is a factor variable and only takes 2 values, we use logistic regression. So logistic regression. So we'll make use of GLM, general linear model, and our independent variable is admit as a function of, so the variables are GRE plus GPA plus rank. And just to keep everything clean, I'm going to put a comma, hit enter and include some more things. So our data for building this model is going to be training data, comma, hit enter. So because we have this admit variable which is factor at 2 levels, so we are going to say that the family equals binomial. So bi means 2, so whenever we have like a variable which takes only 2 values, we can make use of binomial. So we run this and we get this outcome. But let me do one thing. Let's store this in, we can call my logit model. So my logit. So we run this and then we look at summary my logit. So when we run this, it summarizes everything that we have in R. So this is the model, GLM model that we used. Admit as a function of GRE, GPA and rank. We have used a binomial and the data is training. And the main part is the coefficients here. Coefficients of the logistic regression model. So we have coefficient for the intercept, for GRE, GPA, and remember that rank is a factor variable which has 4 levels. So in our logistic regression model we have 3 values for rank. Rank 2, rank 3, rank 4. So if rank 2, rank 3, rank 4 all are 0, that will mean that the candidate belongs to a university that was rank 1. But if we want to represent one applicant which is coming from rank number 4 university or a place, then the value for rank 4 will be 1 and all others will be 0. So if this is 0, this is 0 and this is 1, that will mean applicant belongs to a university which is ranked as 4. But the key thing to look at in this table is p-value, and if p-value is less than, let's say 10%, so less than 0.1, for example this one here, this one and this one, so then we can say that these variables are statistically significant. Now if we conclude that GRE, which is having a p-value of 0.3, is statistically significant, then our confidence level is going to be 1 minus 0.3, which is 0.7 or 70%. So 70% confidence is very, very low. We should have at least 90% confidence. So out of the 3 variables that we are studying, GRE, GPA and rank, GRE doesn't seem to really have a statistically significant impact on whether or not a student will be admitted. So what we generally do is we drop such variables from the model. So let's go back. To remove any variable, you just delete it, and then we can rerun the model and we can again look at the summary. So now we can see that the remaining variables GPA and rank are significant. Now for rank, even one of them, if it is significant, we have to include that in the model. So this is how we develop the model for logistic regression.